and welcome to Compound Interest, a video where we're going to talk about how to use the formula for compound interest. If you're like me, then you've wondered how banks, credit cards, savings accounts, checking accounts, all those different accounts, they make money and how you can make money on your investments. Well, it's a very special equation, and I'm going to teach you more about it today and how to apply it to some of the problems that you're most likely seeing in your courses. So most likely in your class right now, you are using the applications of interest formulas. And today we're going to be focusing on that formula for compound interest. And that's specifically for investments, credit cards, savings accounts, checking accounts. It's what you put in and how much you get out based on an interest rate. This video is specifically for compound over time. There's different equations for continuous compound rates. There's equations you can use for organic chemistry. Today we're going to focus just specifically on compound interest. Here is our beautiful equation that we're going to be using. I'm going to quickly go over each component and then we're going to do a deep dive. And I'm going to give you some tips and tricks of what to watch out for, especially when you're first starting out using this formula. So F of V is your future value. That's what you expect to get out. And with a good investment, right, you're trying to get more out than you put in. Your R is your interest rate. T is the time the money is invested for. That is your years. And N is the times of interest rate is compounded during those years. So most likely in the courses you'll be taking, your compounded rate is either quarterly, which is 4 quarters in a year, or monthly. And how many months are there in 1 year? 12. So 4 and 12 will most likely be the components for your N. Let's go ahead and do a deep dive of the actual formula. And I'll give you some tips and tricks along the way of what I learned when I first started using this formula. So here is our F of V. This is our future value. Again, this is the amount that we expect to get out. And if it's a good investment, it's going to be more than we put in. But we also need to take into consideration our initial amount. So this is the starting amount that we put in, whether that's $500, $1,000, $100. This is what we put in originally. Here is the R. Now, R is the rate. Be very careful with this part. Most likely problems will give you the interest rate, like 8%, 5%, 3%. But if you put that amount inside this equation, you'll get the answer wrong. What the R is asking for in this equation is in decimal form. So what I like to do is immediately do a conversion. So I take my rate over 100 and I get a decimal of something, of some kind of number. And that decimal is what you're going to be plugging in for R. N is a little tricky. N is not what you think it is. N is not like compounded in years. It's compounded in time. So this is the compounded rate over time. Now, if it's quarterly, that is 4, because there's 4 quarters in a year. And if it's monthly, it's 12. There are 12 months in 1 year. This is the easiest part of this equation. T is just the years, and most likely that will be given to you in your problems. All right, so let's dive in and use this formula in real life. Problem number 1. Kale invests $1,000 at 8% quarterly. How much will they have at the end of 3 years? Now, this is a seemingly simple question, but there are some little tricky parts along the way, and I'm going to go through it with you so that you feel very confident using this formula. So I'm going to go ahead and just write the formula right up top here so that we have it. This is the formula that we just went over, and with any problem, I like to find my components. Now, what it's asking for is how much will they have at the end of 3 years. That's my F of V. So I'm going to put F of V with a question mark. That's what I'm trying to find. And here, next, what I'm going to do is find my components. So first is my P, and it says Kale invests $1,000, so that's my starting amount. My R again, is a little bit tricky. So it says 8%. Now I can't just plug 8 into this R or I'll get the problem wrong. What it's actually asking for is it in decimal places. So I'm going to say 8 divided by 100 to get that decimal place, which is 0.08. All right, now I won't get the problem wrong because I converted into a decimal place. N, again, a little bit tricky, but not too bad. You have to read these problems very carefully. It says quarterly. So how many quarters are in 1 year? 4. So N is 4. T is the easiest part. It's the years, and that's 3. So I'm going to go ahead and start plugging in my values into the equation. Now, for me, with my professors and instructors, having a left-hand side, so having this side of what I'm trying to solve for throughout my entire solution is very important. So just get used to writing it because eventually it will be very much a part of your mathematic journey. So I'm going to start plugging in my different components. So here is P, it's $1,000. 1 plus my R, which is 0.08, over N, which was 4, that's the quarters, times N of T, which is 4 times 3. Now I know I could put 12, but I'm going to leave it because we're just learning it. All right, so that is my equation with all of my components plugged in. I'm going to go ahead and plug that into a calculator and see what we get, because that's exciting, right? All right, so I'm going to plug in my P, which is 1,000. That's my initial investment. Don't forget your 1 plus my percentage, which is 0.08, divided by 4. That's the quarters. I'm going to click on this caret. I'm going to get up into the top. I am going to use parentheses. Now again, I can just put 12, but because I'm starting out, I'm going to write all of my answers. Some of the hardest part about doing the compound formula was figuring out how to put it into a calculator. Luckily for compound formula, you're going to plug it into your calculator just as you see it. So make sure you are using your parentheses properly and you're just using all the components that you see. I'm going to click enter, and here is my number, $1,268.24. So I'm going to go ahead and write that as the answer because it is always exciting to get the correct answer. So the correct answer is $1,200, don't forget my dollar sign, US dollars, 68 and 24 cents. That's how much Kale will have at the end of a 3-year investment at 8% quarterly. Not bad. All right. So I hope you learned a little bit more about compound interest and you feel more confident with the actual formula and using it throughout your journey in mathematics, and I don't know, even making a little bit extra cash on your investments in the future. Until next time, I'll see you later. Bye for now.